Okay, so Gabby, what we're doing with simple versus compound interest is when you're looking at simple interest here, so PT, when it says PT, that represents, so for example, that would represent like Y. Y, or that total amount of money, is equal to, and when you see this P with the low subscript O, that means that stands for how much money that you start with. So in Chase's example, I believe he started with $1,200 that he was going to put in that bank account. So you would have to do that initial amount. So it would be 1,200, right, is equal to your PT. And plus to that, add to that your PO again. So you have to take that PO again, which is 1,200. And you have to multiply it by that rate. And I believe with his simple interest one, which was the basic, his interest rate was 6%. So you would write that as 0.06 and then multiply it by our time in years. And I believe in that example, when we're talking about Chase, his time was 5 years and 15 years. So you're going to have to solve this for that total amount of money. You have to solve it for 5 years and then 15 years. So you're going to have to plug 5 in here, and then you're going to have to solve it. And then you're going to have to plug 15 in here and solve it. So now when we're talking about this compound interest is different than simple interest. Because remember, up in simple interest, you're only gaining money on that initial amount that you put in. You're not gaining interest on that money that interest that you make. So if you're thinking about like a bank account that you have, any bank account that you would have would be this compound interest, because in a compound interest equation, you have the only time that you're talking about with that PO, right, is when you're talking about that first interval of time. So for example, if your equation compounds every year, that PO is only going to be used in your year one. So for example, let me explain it a little bit better. I don't think I'm really explaining it well. So with the compound, you earn interest on the interest that you make. So let's take a look at the equation and what each of these things means. So let's take a look. So we have the same thing. We always start with our PT or our Y. So that total amount of money that you're going to have in your bank account is going to be equal to, you're saying again, that PO, or that initial amount of money that you're starting with. So in Chase's equation, he started with the 1,200. But instead of adding like we did in our simple interest rate, we're going to have to multiply it by 1 plus our rate of change. And he said in this, our gold account, so this is our gold account, our compound interest is our gold account, his interest rate was a little bit different. His interest rate that we're going to be adding to it was 4.5%, so it would be 0.045, right? And then this time, instead of multiplying by t like we did up in our simple, we're going to have to raise it to the t power. So that means the number of years, you're going to raise this number in the parentheses here to that number. So if you were to be looking at, for example, 5 years, let's take a look at how much money the gold account would have after 5 years. So we would say to ourselves, PT is equal to 1,200, right, times 1 plus 0.045. Raise it to, we said we're going to look at 5 years, so we're going to have to raise it to the 5th power, okay? So let's take a look at what this would look like. Give me one moment, Gab. I don't have another board right here. Sorry, sweetheart. So, this is kind of crazy. I get that. We would say PT is equal to 1,200 times the 1.045 raised to the 5th power. So, what are we going to have to do first here? We're going to have to do our exponents, right? Because we're looking at that PEMDAS. So we're going to have to do this piece right here first. So let me pull up my calculator and let's take a look at what that's going to get me. Sorry, Gabby. Calculator. Okay, again. So we have this. Let me write it again. It got smudged. I'm sorry. So we have this 1,200 times 1.045 to the 5th power, because we added 1 plus the 0.45, so we get 1.045, and we know that we have to do that exponent first. So when I use my calculator, I would type in 1.045, and I would raise it. Let me find my so I'd raise it to the 2nd power. So boom, and I would get an answer of 1.09, and then it's 2. So it would round to 1.09, and I would have to now, if I look at it, bring down my times it by 1,200 equals PT, right? And P5, and then I would have to multiply 1,200, so I'd come back over to my calculator, times it by 1,200, boom, I get $1,310.43 after how many years? P5 years, okay? So what I'm going to say is, so when you have an account that has compound interest, right? Okay, so when you say, for example, you were born, your parents put $1,000 in an account. Every year, you compound your interest. So let's say in that first year that you had the account, you made $500 in interest. So then you would have $500 added to that. You had 1,500. So the key difference is, in a simple interest equation, you would simply keep adding $500 each year. But because we're talking about compound interest, we take now our new initial for that second year is gonna be 1,500, and then we'd have to multiply that by our rate of change. So the key difference between simple and compound is that with simple, you use that same initial every single time, but with our compound, we get a new total at the end of each cycle, and that's the B or PO that we're going to be simpling, or what am I saying? Putting in every time. Okay, so let's that's. Gabby, I gave it my best shot. I mean, I'm very bad at recording, and if you're still unclear, let me know, and I can try to do something else tomorrow. But just wanted to give this to you now in case like you were freaking out. So give it your best shot. Let me know. Okay, bye.